The working group RFC-2822. I'm Shivali, and I'll be presenting the introduction of our presentation. So the first part of our introduction is the scope of this presentation. So this internet standard specifies a syntax for text messages that are sent between computer users within the framework of an electronic mail message. So the standard supersedes the one specified in RFC 822. The standard specifies a syntax only for text messages. So transmission of images, audio, other forms of data through electronic mail messages cannot be done. In the context of electronic mail, messages are viewed as having an envelope and contents. The envelope contains whatever information is needed to accomplish transmission and delivery, whereas the contents comprise the objects to be delivered to the recipient. The standard applies only to the format and some of the semantics of the message contents and contains no specification of the information in the envelope. However, some message systems may use information from the contents to create the envelope. It is intended that this standard facilitates the acquisition of such information by programs. The specification is intended as a definition of what message content format is to be passed between systems. Though some message systems locally store messages in this format and others use formats that differ from the ones specified in the standard, local storage is outside of the scope of this standard. The standard is not intended to dictate the internal formats used by sites, the specific message systems feature that are expected to support, or any of the characteristics of user interface programs that create or read messages. In addition, the standard does not specify an encoding of the characters for either transport or storage. That is, it does not specify the number of bits used or how those bits are specifically transferred over the wire or stored on disk. So the second part of this presentation are notational conventions. So there are certain conventions that have to be followed and have been followed throughout this presentation. So they are the requirements notation and syntactic notation. So requirement notations. So throughout this presentation, there is occasional use of terms that may appear in capital letters. Terms such as must, should, recommended, must not, should not, may appear capitalized, and they're being used to indicate particular requirements of this specification. So the next convention is the syntactic notation. So the standard uses the ABNF, that is the augmented Backus NOF form, for the formal definitions of the syntax of messages. Characters will be specified either by a decimal value or by a case-sensitive literal value enclosed within quotes. So the third part of the introduction is the structure. So a presentation has been divided into 5 sections. The first section is the current section, that is the introduction. So the second section is a lexical analysis of messages that lays out the general description of a message and its constituent parts. This helps in understanding some of the general principles used in the later portions of this presentation. Section 3 is the syntax and specifies formal ABNF rules for the structure of each part of a message and describes the relationship between those parts and the meaning in the context of a message. That is, it describes the actual rules for the structure of each part of a message, as well as a description of the parts and instructions on how they ought to be interpreted. This includes analysis of the syntax and semantics of subparts of messages that have specific structure. So the fourth section is the obsolete syntax. The rules of obsolete syntax are elements that have appeared in earlier revisions of the standards or have previously been widely used in internet messages. So the last and final section are the security considerations that have to be taken into account when implementing this document. So these are the 5 sections into which we have divided our presentation, and this was the introduction to our presentation.
Good morning, sir. My name is Ritika, and I'm going to cover the second section of this standard, that is lexical analysis of messages. The topics under this are first the description, then its line length limits, then the header fields, and then the body. Now moving on to its description. So as the basic level of message is a series of characters, and this standard is made of ASCII characters, which basically means that a message is comprised of values ranging from 1 to 127. Therefore, this document is also sometimes referred to as the American Standard Code for Information Interchange Characters. Now, messages are divided into lines of characters. So there are 2 types of these characters. First is carriage lane and line field, which so carriage lane has an ASCII value of 13, and line field has an ASCII value of 10. A message consists of header fields and body, which is optional. So basically, header field is a sequence of lines of characters with special syntax as defined in the standard, and the body is simply a sequence of characters that follows the header field and is separated from the header by an empty line. Next, we have the line length limits. So there are two limits that the standard places on the number of characters in a line. Each line of characters must be no more than 998 characters and should be no more than 78 characters, excluding the carriage lane line feed. The 998 character limit is due to the limitations in many implementations which send, receive, or store internet message format messages that simply cannot handle more than 998 characters in a line, and so many implementations, and there are so many implementations which do not accept messages containing more than 1,000 characters. Now, the more conservative 78 character recommendation is to accommodate the many implementation of user interfaces that display these messages, which may truncate or disastrously wrap, in spite of the fact that such implementations are not compatible to the intent of the specification. So, therefore, it's mandatory to put such implementation on these messages for the sake of good quality and condition. So in this slide, I'm going to discuss header fields and the type of header fields. So header fields are lines composed of field name followed by a colon and a field body, and it's terminated by CRLF. There are some rules that the field body follows. So firstly, a field name must be composed of printable ASCII characters, that is characters that have values between 33 and 126 inclusive except the colon. Secondly, a field body may be composed of any ASCII characters except for CR and LF. However, a field body may contain CRLF when used in header folding and unfolding. And also, all field bodies must conform to the syntax that is described in the following sections. So the first type of header field is unstructured header field bodies. So some field bodies in this standard are defined simply as unstructured, that is specified as any ASCII character, except for carriage, return, and line feed with no further restrictions. Those are called as unstructured header field bodies. And semantically, these are simply to be treated as a single line of characters with no further processing, except for header folding and unfolding. The second type of header field is structure header field bodies. So some field bodies in this standard have specific semantical structure more restrictive than the unstructured field bodies, and those are called as structure field bodies. Unstructured field bodies are sequences of specific lexical tokens, and a lexical token is a string with an assigned and thus identified meaning. Many of these tokens are followed to be introduced or end with comments, as well as the space with which has an ASCII value of 32, and horizontal tab denoted as H tab, which has an ASCII value of 9. And together, these characters are known as white space characters, and those white space characters are subject to header folding and unfolding. The semantic analysis of structure field bodies is given along with their syntax. So the third type of header field is long header field. So each header field is logically a single line of characters comprising the field name, the colon, and the field body. For convenience, however, and to deal with the 998 or 78 characters limitations per line, the field body portion of a header field can be split into multiple line representation, and this splitting is called as the folding. Those structured field bodies are defined in such a way that the folding can take place between many of within lexical tokens. Folding should be limited to place the CRLF at higher levels synaptic breaks. Now, the process of moving from this folded multiple line representation of a header field to single line representation is called as unfolding. Unfolding is accomplished by simply removing the CRLF that is immediately followed by white space. Each header field should be treated in its unfolded form for further synaptic and semantic evaluation. Now I'm going to explain folding with an example. So this is the structure of header field where subject is written like this. This is a test. Now this can also be represented as this and is a text in the next line. So this happens because wherever this standard allows for folding white space, not simply the white space characters, a CRLF may be inserted before any white space. So therefore this explains the whole folding process. Lastly, talking about its body. So the body of a message is simply lines of ASCII characters. So there are only two limitations in the body, and these are as follows. So firstly, carriage return and line feed must only occur together as CRLF. They must not appear individually in the body. And secondly, lines of characters in the body must be limited to 998 characters and should be limited to 78 characters, excluding the CRLF. Also, there are other standard documents, specifically the MIME documents, that's multi-purpose internet mail extension, that extend the standard to allow for different sorts of message bodies. So, rest of the teammates are going to discuss further about this standard.
Hi, this is Priyanka, and I'm here to talk about Section 3, which is syntax of RFC 2822. So, moving on to the introduction, the syntax defines the legal syntax of the internet messages, which are the messages which are conformant to this standard must conform to the syntax in this section. So, for the defined expressions, a short description of the syntax in use is given, followed by the syntax in ABNF, followed by a semantic analysis. And in all cases, the productions are to be ignored for the purposes of generating legal internet messages and must not be used as a part of such a message. However, when interpreting messages, these tokens must be honored as a part of the legal syntax. So talking about lexical tokens, the following rules are used to define an underlying lexical analyzer, which feeds tokens to the higher level parsers. So these are the primitive tokens, followed by this. And no special semantics are attached to these tokens. They are simply single characters. Okay, moving on to the next one. Coded characters. Some characters are reserved for special interpretation, such as delimiting lexical tokens. So to permit the use of these characters as uninterpreted data, a coding mechanism is provided, which is here. Folding white space and comments. So white space characters may appear between many elements in header field bodies, and also strings of characters that are treated as comments may be included in structured field bodies as characters enclosed in parentheses. A comment is normally used in structured field body to provide some human readable informational text. Since a comment is allowed to contain FWS, folding is permitted within the comment. The next one is atom, which are these three. Yeah. Several productions in structured header field bodies are simply strings of certain basic characteristics. Such productions are called as atoms. As I showed below, the A text along with these three are the atoms. Both atom and dot atom are interpreted as a single unit comprised of the string of characters that make it up. Moving on to quoted strings. Strings of characters that include characters other than those allowed in atoms may be represented in a quoted string format, where the characters are surrounded by quote characters. So, the miscellaneous tokens, there are three additional tokens. Three additional tokens are defined: word and phrase for combinations of atoms, and quoted strings and unstructured for use in unstructured header fields and in some places within structured header fields. Date and time specification, these occur in several header files, and this section specifies the syntax for full date and time specification, which are as follows. The next one is address specification. So addresses occur in several message header files to indicate senders and recipient of messages. And an address may be either individual mailbox or a group of mailboxes. So the ADDR spec specification is a specific internet identifier that contains a locally interpreted string followed by the @ sign. character followed by an internet domain. So the locally interpreted string is either a quoted string or a dot atom. The next one is overall message syntax. A message consists of header fields, optionally followed by a message body. Lines in a message must be maximum of 998 characters, excluding the CRLF, but it's recommended that lines be limited to 78 characters, including the CRLF. Moving on to the next one are the field definitions, which you can see in the tabular columns. The header fields of a message are all defined here, and all header fields have the same general syntactic structure. A field name, which is followed by a colon, followed by the field body. The specific syntax for each header field is defined in the subsequent section. Okay. So the next one is the origination date field. The origination date field consists of the field name date, which is followed by a date time specification. So for instance, this might be the time that a user pushes the send or the submit button in an application program. The next one is the originator fields. The originator fields consists of the from field, the sender field, and the optionally the reply to field, which are mentioned here. The from field consists of the field name from and a comma, separated list, and one or more mailbox specification. The next one is the destination address field. The destination fields of a message consists of three possible fields, each of the same form. The field name, which is either to or CC or BCC, followed by a comma separated list of one or more addresses. Next is the identification fields. Though optional, every message should have a message ID field, and the reply messages should also have in reply to and references fields as appropriate as described below here, in reply to, references, message ID, etc., etc. Next one are the informational fields. The informational fields are all optional. The keywords field contains a comma separated list of one or more words in the quoted string. And the subject and the comments field are also unstructured fields and therefore contain text or folding white space. The resent fields. Resent fields should be added to any message that is reintroduced by a user into the transport system. So each set of new resent field is prepended to the message. That is, the most recent set or recent fields appear earlier in the message. No other fields in the message are changed when the recent fields are added. These are the recent fields. Next one are the trace fields. The trace fields are a group of header fields consisting of an optional return path field and one or more received fields. The return path header field contains a pair of angle brackets that enclose an optional ADDR spec. So the received field contains a list of name or value pairs followed by a semicolon and a date time specification. Moving on to the last one are the optional fields. Fields may appear in the messages that are otherwise unspecified in the standard, and they must conform to the syntax of an optional field. So the field names of any optional field must not be any identical to any field name specified elsewhere for this standard. So for the purposes of this standard, any optional field is uninterrupted. Thank you.
I'm Dhruvan Ajit Pranta, and now we'll discuss about section 4 of RFC-2822. In this section, we'll discuss about obsolete syntax. Earlier versions of this standard allowed for different, usually more liberal syntax than is allowed in this version. Also, there have been synthetic elements used in messages on the internet whose interpretation have never been documented. Though some of the synthetic forms must not be generated according to the grammar, they must be accepted and analyzed by conformant receiver. This section documents many of these synthetic elements. Taking the grammar and adding the definition presented in this section will result in a grammar to use for interpretation of messages. This section identifies synthetic forms that any implementation must reasonably interpret. However, there are certainly intent messages which do not adapt to even the additional syntax given in this section. The fact that a particular form does not appear in any section of this document is not justification for computer programs to crash or for malformed data to be lost by any implementation. Lines in messages to be no longer the 998 character, discarding the 999 and subsequent characters in a line without warning would still be a bad behavior for an implementation. It is up to the implementation to deal with messages forcefully. One important difference between the obsolete and the current syntax is that in structured header field bodies, white space characters, including folding white space and comments, can be freely inserted between any syntactic tokens. This allows many complex forms to have proven difficult for some implementations to be analyzed. Some of the obsolete tokens are miscellaneous obsolete tokens. These syntactic elements are used elsewhere in the obsolete syntax or in the main syntax. One important point to note here is that BACR and BACLF appear in messages with two different meanings. In many cases, BACR or BACLF are used improperly instead of CRLF to indicate line separators. In other cases, BACR and BACLF are used simply as ASCII control characters with a traditional ASCII meaning. With obsolete folding white space, any amount of folding white space may be inserted. Obsolete addressing, there are three primary differences in addressing. First, mailbox addresses were allowed. Second, CFWS were allowed. And third, mailbox list and address list were allowed with null members. Obsolete header fields, in which we have obsolete originating date field, obsolete destination address fields, obsolete identification fields, obsolete present fields, and obsolete trace fields. Now we'll discuss about section 5, which is security considerations. CAN is to be taken when displaying messages on a terminal or terminal emulator. Powerful terminals may act on escape sequences and other combinations of ASCII control characters with a variety of consequences. They can revamp the keyboard or permit other modifications to the terminal which could lead to denial of service or even damage data. They can trigger unspec messages which can allow a message to cause commands to be issued on the recipient's behalf. They can also affect the operation of terminal attached devices such as printers. Message viewers may wish to strip potentially dangerous terminal escape sequences from the message prior to display. BCC blind carbon copy. Mishandling of this has implications for confidential information that might be revealed, which could eventually lead to security problems through knowledge of even the existence of a particular mail address. Thank you. This was section 4 and 5 of RFC 2822.